All right, we are going to get started. It is 4 o'clock. I want to thank you all so much for joining us. If you did not know, this is CS Week, Computer Science Week, all week long, and we're going to celebrate it with you for this next hour. Get you excited.
Is it me?
All right, sorry, we had a little bit of technical difficulties. Hopefully that's the only. We might have others. Bree's microphone was picking up me talking, and we had some reverb through the speakers. So, but anyway, I want to thank you all for joining us. I want to thank you all for being on a robotics team. You may or may have heard me say this before, but I think being on a robotics team is one of the best things that you can do when you're in school, or if you're a teacher or a mentor, it's one of the best things we can provide for our students. We get a lot of questions asking, I want to learn how to program my robot. New this year, VEX just came out with some new software called VEXcode IQ Blocks. Eventually, they're going to release a text version of this. So we're going to use today VEXcode IQ Blocks. We're going to walk you through some of the very basics. Each of you that are joining has a little bit more experience or a little experience. Some of you have no experience at all. So we're going to kind of walk through the very, very basics, and throughout the evening today, it'll get a little bit more complicated. Before we dive in, I want to introduce you to some people that are behind the scenes that are going to be helping me. So you may have seen these people at one at State, and then another, we have a new coworker of mine. So I want to introduce Andy over here.
Hey everyone.
This is Andy Fulton.
Yeah, you probably were the one. I was the one that you were getting all the emails from. So I'm the volunteer and events coordinator here at Tech Point Foundation for Youth.
And then over here we have Bree.
Hi everybody. Nice to see you. Thank you for being here.
Sometimes we call ourselves the robot team. So we're the three that work primarily on the Robotics State Initiative and getting robotics opportunities to the students. So we'll be behind the scenes. And then we also have Steve Hassenplug on the call as well. He'll be answering questions, and he is the one that did the lessons for this evening. Just before we dive in, I want to kind of go over a couple things. This webinar is intended for students, whether you're a first grader or an 8th grader or anywhere in between there. This is intended for elementary and middle school students, teachers, coaches, mentors. I'm happy for you to listen and go through these activities, but if you have students in the room, this night and evening is for the students. So students, tell the adults to not touch the robot, don't touch the computer. This is your evening to learn about coding. Programmers in the room, if you're listening, you can hear me. Hello, thank you for being programmers. What I'm going to ask you to do is, if you have any other students in the room that have never programmed or not even on the program team, I'm going to ask you to look over in the room right now and bring them over to you in this webinar to join us, because we want this evening to be about showing everyone on your robotics team how to code their robot. So I know sometimes there's only 1, 2, or 3 people on a team that are the coders, and the others are builders or drivers or whatever. We want to make sure that everyone on your team has just an opportunity tonight to learn how to code. The way the format of the evening is going to go is we're starting at 4. We're already 3 minutes in. We're going to stop at 5. The way it's going to work is when I'm done giving an introduction, we're going to show you a lesson on how to get started with VEXcode Blocks. Just the very, very simple basics. It lasts about 15 minutes. We're going to play, it's kind of a already pre-recorded video. So we're going to play the video, and then we're going to pause it. During that time, if you have questions, you can feel free to ask the questions in the question box. Steve Hassenplug, who did this video, is in there answering questions. Bree and Andy will be answering questions. But feel free to kind of listen to the video, do the activities as we go along, and then we'll take about a 5 to 8 minute break, depending on where we're at on time, to allow you to try to test out everything that we did. So it's kind of, here's something new, now you try it. That's kind of the way this evening is going to work. And then around 4:30 or so, we're going to show you the second lesson. And the second lesson will be a little bit more complex. There will be more functions that we'll show you, and different features of VEXcode Blocks that you can use for your robot. And then again, we'll end it with allowing you time to try it and ask any questions that you have. If you have any connection problems, there is a dial-in number that you can call with your phone so that you can listen in and just watch the webinar portion if you have audio issues. And then if you have total, internet issues or it closes out, I apologize. I'm sorry. I hope it's not from our end. But I am recording this video right now, and I will send this out to all teams afterwards. In fact, Andy will probably send this out to all teams afterwards so that you can watch it at your own pace if we go too quickly today. And again, as I said, this is an opportunity for students to learn more about coding. Some of you joined or plan on joining us tomorrow, Wednesday, and then on Thursday. And each day we are going to go in more and more depth on how to program your robot a little bit more, how to completely autonomously program your robot. And Thursday we're going to introduce the gyro sensor, and we're going to end the evening with showing techniques on how to get better at skills, because you may or may not know skills challenges are one of the easiest ways to get to state. So every time you go to competition, make sure you take advantage of those skills challenges. So I'm going to stop talking. I'm going to play our first video, which walks us through VEXcode IQ Blocks. Again, open up your computers if you haven't already. Open up the software, turn on your brain, your human brain and your robot brain, and get your micro USB cable ready, and we'll follow along. So feel free to ask questions. Steve did a wonderful job of putting this together. So I'm going to shut off my webcam. So is my webcam off now? All right, and now I'm going to put up our first video, and I'm new to this software, so be patient with me, please. Let's see, does the video go up? And you may have to adjust the volume.
Hello. Today we're going to have an introduction to VEXcode IQ Blocks. We're going to create a pretty simple driver control program. Before we start, you want to make sure that you've already updated your brain, the controller, and the devices you'll be using to the latest version of the firmware. You also want to install the latest version of VEXIQ code blocks. VEXcode IQ Blocks. Quick overview, we're going to talk about why we want to use the default ports. We're going to create a simple program. We'll configure all the devices in that program. We'll download it and test it and do a little bit more configuration of the devices, and then download and test it again. First, a tip. Whenever it's possible, it's a good idea to use the standard driver control program ports, because if something goes wrong with your program, or if you need to do some testing before the program's actually written, you can just use the default driver control program. And we've got a list of the motor ports here. If you use port 1 and 7, those will be your left drive. 6 and 12 is your right drive. Motor port 4 is directly controlled by the R up and R down buttons. Motor port 10 is controlled by the L up and L down buttons. One of the reasons for using these is if a motor fails at a competition and you need to run your robot immediately, then you can use the standard driver control program, because it will ignore motors that are not connected, and so it will still work with the program that you may have in there, or with the ports you have connected. So you can just use it directly without changing anything. So first we're going to start by creating a program. So we'll open up our VEXcode IQ Blocks. All right, so now we have our VEXcode IQ Blocks software open. We're going to go ahead and create a simple program. So first we'll click on the name, and it'll come up and allow us to save a new program. And it should continue to save this as we make changes to the program. You can, if you want to, select your slot that the program is going to be saved into. It will maintain this slot with the program. So if you always have your driver in slot 1, then you can go ahead and just set it on slot 1. So now we can open our devices. We have no devices in this program yet, so I'm going to go ahead and add a device. And I will add a simple clawbot setup. So I'll put motor on port 1. The right motor is going to be on port 6. And I will turn off the gyro because I won't be using that today. You'll see this configuration is fairly standard. We can make some changes to it. Right now we're just using the standard setup. And I have a few more things that have appeared in my list. So now I can go ahead and add another device. I'm going to add a motor on port 4. This is going to be my ARM motor. So I'll go ahead and change the name to ARM. I'll go ahead and change this so that this is up and this will be down. Done. And I've got a few more things that appeared on my list. Now I have another motor I'm going to add to port 10. This will be my claw. And I'm going to say I want to open and close my claw. Now finally I'm going to go ahead and add my controller. And I'm just going to go ahead and jump ahead and set this to left and right drives. So I can just click on that and it'll cycle through. We'll talk about the others in a minute. And I'm going to set the right button to control port 4, the ARM. And I'll set the left to control port 10, the claw. Then I'm done. And now my program's complete. I can go ahead and download that to my robot. And with my remote control on, which I didn't have on, I can go ahead and run the program. And now it's able to drive my robot. So now I have my program all downloaded on the robot. I have motor ports are connected. I can drive one side or the other. I have the claw connected to the left button. I have the arm connected to the right button. Now you see it moves a little bit slow. And also we see the claw doesn't always want to hit the close button. I'm just hitting the close button and it's sort of bouncing open and closed. What we see also with the motor right now is it won't hold its position. If I tell it to go back up, I can actually just push it down. So there's a couple other settings we need to make on our program. So we're looking at our program again. There's a couple changes we want to make. First of all, we can hide our device panel. So we notice when the arm went up, it went up kind of slow. And so I want to go ahead and grab this and set the arm velocity so I can just drag this over. This means when the program is started, I'm going to go ahead and set the arm to 100%. So the arm's going to go at full speed. Now the other big issue that we had was the arm wouldn't stay in place. So I'm going to drag this, say, so that when the arm stops, I'm going to set it to the hold mode. Now, it was initially set to coast, so it was pretty free to move when you weren't driving it to a specific direction. The brake mode, if you set it to brake, then when you let off the button, the motor will kind of resist moving, kind of like putting on the brakes. What we want it to do, we want it to hold its position. So we'll tell it just to hold there. And for the claw, I'm going to add a claw here. Set this for the claw motor. I actually just want to have it set to brake. So it's kind of going to hold its spot, but it's not really going to stay right where it was. So with those few little tweaks, I'm going to go ahead and download my program again so we can take another look at it. So now I have the robot running with a new program on it. See, the arm is very deliberate when it moves. Claw is the same way. And if I try to move the arm, it holds its position very well. That's automatically holding the position. Okay, so now we've completed our first program, and we can go in and make some changes to it.
All right, can you guys hear me? All right, so we're getting some messages that things are going a little bit quickly, and I apologize, that is not the intent for this. We did a pre-recording of this so that we can get everything to work with the video and the screen share and a webcam and all those things at the same time, which is really difficult to try to do live. So this is our first try at it. I really apologize if we're moving too fast. We also have first graders and eighth graders in the webinar. So some people are going quickly, some are not. So just as a reminder, this is all going to be recorded. We will send this out as well if this is going too quickly. I will back up the video. So this is, I'm really going off on an audible here, if you will, on something different. Wasn't planned, but I'm getting a lot of questions saying we're moving too quickly. So let me just kind of start, not back at the beginning, but let me just start kind of in the early, when Steve starts going over a few things, which is roughly, and I hope I can rewind the video. I don't know if I can because I've never done this. It doesn't let me rewind the video, so that's not going to be helpful. That's too bad.
To it.
Okay, so it's not letting me rewind the video, but I can point some things out to you. In the very beginning, the whole purpose of what Steve is trying to show you is that a lot of teams use the default driver control to drive the robot. And what Steve set up in the very first 4 steps was showing that this is a way for you to customize your remote control so that you can drive this a little bit different, a little bit more autonomously, so that you can customize the functions and buttons and you don't use the default. All of you have different robots. Some of you guys have a robot that looks just like the clutch bot or the claw bot or the stretch bot. Each of you guys built a different robot from the command. Some of out of the step-by-step instructions. You build your own design. But most all of you use a robot with a left motor drive and a right motor drive. And that's what Steve did in the very beginning with the drivetrain, is he took the left motor that controls your left wheel, and he said that's hooked up to 1. And then he took the right motor, and he followed the wire, and he said, yep, that's hooked up to. Then he unclicked the gyro on there, which we're not using the gyro in this activity. Okay, so that was just the drivetrain setup. And what that did, if you didn't notice, is it gave you a bunch of commands on the left side. Are you able to see my mouse or not? I'm sorry, you can't even see my mouse right now. What it did is allowed you to see, what if I do a spotlight? Can you see now? No? Okay, well, if you look on your left menu bar, it gave you drivetrain options. It gave you drivetrain functions that say drive forward, left, right, things like that. And then it doesn't matter what kind of robot you build. What Steve did is he was saying if you have a robot that has an arm that lifts up and down and a claw that opens and closes, he did an arm for arm 4 and a claw for port 10. And so he hooked up these two, just as if you had a claw bot, your arm that goes up and down would use port 4. The claw would be open and closed as if you use something to grab something, you use that to port 10. And then and you saw Steve kind of cycle through, you can play with those different functions. You don't have to match exactly what Steve did for the controller functions. You could do a different layout. It's almost like, I give an analogy or example of when you play a video game, sometimes you like to have the jump button to be A, sometimes you like the jump button to be your left finger, your index finger. So that's how robot driving can be. If you want the lift to be on the right side, or lift means left side, maybe you do it the left side. You can change the button layout however you like. That's the whole purpose of what Steve is trying to show you how to do in this video. Okay, so just to recap, drivetrain, left motor, port 1 and 6. That's where it is hooked up. Arm, your arm might look different. He's putting it by default on what's on the claw bot or the stretch bot. So that's on, or the clutch bot. That's on port 4, and then the claw would be the open and close. That's port 10, and then the remote, we all have the same exact remote, so that one doesn't matter. Okay, so that was just the full layout, and then Steve, that turned green, and that was the pre-video we sent out to the teachers to show that you can download it. That's when you hook up the remote or the brain to the program, and it turns green. When you hit download, it takes your code and it puts it on the robot. So you can hit program 1, or in this case, he put it on slot 1, so you can put on program 1, he called it driver. You can hit start and you can test it out. Okay, so that's me explaining everything up to this point. And then what Steve showed you in the video is that in the video portion, he could push up and down on the arm and it moved. And why that's a problem, if you think about it, if you're picking up a cube in this year's game, the cube would fall as soon as you let go of the button. It would just fall down. So what Steve's saying is, well, let's put he called it a hold on the arm so that it would not fall down when you pick up something heavy. So when you push up on it, you're carrying that block, you put hold, it holds it into place. And then on the claw part, he put a brake function. And then the last thing he had, or which was, I guess, the first thing he had, was the velocity. That was just increasing and decreasing the speed. So again, I'm not here to sugarcoat and say programming is the easiest thing to do. It's a challenge. I mean, everything we do in robotics is a challenge. It's hard. Everyone learns at different paces. So please don't get discouraged if we were moving too quickly. Please don't get discouraged if you didn't catch all of this. You can go back and watch this video. I'm just telling you to send this message. Students, listen up, please. Do not be discouraged if you thought this was hard, what Steve did. We all have to start somewhere. So please, 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 do not give up, okay? I will tell you, I had Steve do this because I don't know how to program the way Steve does. Steve He gets paid money to program. That's why we had Steve do this video. So I too struggle with programming, and I have to go slowly, and I've already watched this video. That's why I know a lot of these things. So please don't get discouraged if this is your first time. Please don't be discouraged if this isn't coming easy to you. It takes practice, okay? It's just like a sport. You have to learn how to dribble a ball before you can start running and shooting and do layups. You have to take baby steps sometimes. So we're going to take our time with it. So I'm going to resume the video now. Steve has now added the set arm velocity, the set arm stopping to hold, and set claw stopping to brake. So what that's going to do is it's going to speed up the speed of the arm. It's going to hold the arm, and it's going to break the claw, not break it in half, but add a brake like brakes on a car to stop it. So those are the 3 commands he's adding. And so I'm going to resume the video. There's still about 5 minutes left of this video. I'm going to resume the video, and then I'm going to allow you to ask questions to Steve. And then I'll just give you a heads up if that's all you want to do after this video and ask questions to Steve, please do so. The second video he has is a little bit more complex. So if you start watching the second video and you're saying, whoa, the first video was tough, the second one might be way too tough, please, again, don't get discouraged. We can walk through, you can walk through this at your own pace at school once the video comes out, the actual when we send out the video. So I'm going to resume now, and again, take your time with this. It's okay. We're here to we're here to answer your questions.
This one works fine for the robot that we have. We may have a different type of drivetrain, different arm configuration. So there's a couple options that we can look at for how to configure. Normally, most of our robots will be using the 200mm wheels. Both the Omni wheels and the rubber wheels are 200mm, so you probably won't have to change that in most cases. There is a larger 250mm wheel that you use in some cases. Normally we'll just stick with the 200mm. The track width is actually the width between the wheels, between the left and right side wheels. So if you have a wider robot, you may need to change that. This will affect how it turns. Doesn't really affect how it drives straight, but just when you're trying to use different functions for turning, you'll want this track width set. The gear ratio will mostly affect how far it moves when you're telling it to drive forward. Maybe you'll want it to drive forward 5 inches. This is where you'll put in your gear ratio. Your input would be the gear that's on the motor. Your output would be the gear that's attached to the wheel. And then finally on this, you can change, if for example you set up your motors geared a little bit different, you may need to change which direction is forward or backward. So we can just select forward or backward on the drivetrain. We have similar configuration on our arm. If we mount it on the other side, we may need to reverse the direction of the arm. And that will just change how it functions. We have the same, of course, on our claw, where we can change, make it open or close in a different way. Finally, our controller. We have a few different options for the driving, whether we want it to be a single joystick to control it. This is more like an arcade, where you'll have one joystick to move forward or turn. We can also have the other joystick control it if you want it to be the right joystick instead. This one I think may be a little bit easier for some younger operators. We have one joystick will just make it go straight forward or straight backwards. And then the other joystick will control the turns. A lot of times when you see your drivers, they'll be pushing the joystick sideways with the other type of drive system, and it just doesn't have any effect on it. So this allows them to actually use one joystick to make it turn, with the other joystick to make it drive straight forward or straight backward. We also have, finally on this, we have the tank drive, where you're driving the left joystick drives the left wheels, right joystick drives the right wheels. And this is where if you move the joystick sideways, it won't have any effect at all. Finally, we have the arm, and you'll notice when I clicked on it once, it automatically brought it up and said that this button is the up button and the other button is the down button. And if we don't like how that works, we can actually go back to, I'm going to exit out of here, go back to the arm and change the direction and hit done. And now, effectively, we've just switched which way's up and down. So now the top button will drive the other direction, or the bottom button drives down versus up. So if we need to change how we're controlling the robot, which button does something, we may have cases where the driver thinks the top button should close the claw and the bottom button should open the claw. And we can just go back into our claw configuration and set it up that way. Finally, if you have additional motors set up, sometimes you have a motor set to strafe, go sideways. You can also use your configuration. We'll just go ahead and add in another motor here. And we'll just say this is in port 8. And this will be our slide motor. And I can just as easily connect that to one of the E up or E down buttons, or F. Now you'll notice it'll only let you connect that to one button. So any one function, I can turn these off and connect them however I'd like to have them connected. And if I change my mind about this, I should just be able to go in here and delete this. And I'll go back to my controller and see it's no longer connected there. So there's a fair amount of customization you can do within the settings here, just under the devices, without really doing much programming. Next, we're going to get a little bit more into actually programming, using more steps in the code instead of just the configuration of the devices.
All right, so I will now be taking over as George had to slide off into another meeting. But now we're going to give you time to kind of work on this on your own. So I'm going to throw 7 minutes, just because we're a little bit behind schedule, throw 7 minutes up on our little try it on your own segment. Now, if you feel confident enough to code your robots, go ahead and do that. We encourage you to get as involved as you can. But if you want to take this time just to ask questions, like George was saying, we've got Steve, who I don't know if we formally introduced him, but he is a coding guru. I think he works for REC, so he will be able to answer all of the questions that you have. So I'm going to have this 7 minutes playing. And ask questions, code on your own, and try your hardest. I know coding can be frustrating, it can be challenging. I myself am learning how to code during this hour of code week. Just know that we can all do it, we can all figure it out. We'll send this video out so that this won't be the one and only time that you have an opportunity to code, that you'll be able to code whenever you have these practices, or whenever you have some free time to do some coding. So I'm going to put the 7 minutes on the clock, let you all kind of get to work, try some of the different things that Steve talked about, ask questions. I'll have Steve answer them, and then after the 7 minutes are up, we'll go into the second video. Steve just let me know that he is getting your questions, so he is taking time to read through those and answer right now. So if you don't see an answer right away, know that he is getting to them. All right, so I think that was a quick 7 minutes, but I hope you all had the chance to either ask the questions that you needed to ask or had the option to begin coding a little bit yourselves. So I did get a lot of your questions. I see that Steve is responding to them, so make sure you're checking back into that feature to see the answers to your questions. So for this next video, Steve wanted me to let you know that there's no actual coding during this next video. So this might be a time for everybody to take a deep breath. I'm gonna do it with me. And we'll just take a look at all the functions that the VEXcode blocks have to offer. Again, we know that this is really challenging. Coding is not easy. Like George said, it's something that requires practice and practice and practice. But being able to code at such an early age as all of you are, you guys are going to be set up for the future. So keep on trying. We encourage you to watch this video again in the future once we send it out, and make sure that any questions you have are asked. And we'll jump right into the second video. So just like last time, we'll watch the video, I'll give you some time to play around with it, and then we'll close out the webinar for this evening. Okay, so here's the second part of the video. It looks like it's about 16 minutes, so that'll put us right up into 5 o'clock, so we'll do a quick outro. I just want to reiterate, you all can do it. I would say sit back, maybe take some notes if you have the ability, but this will set you up for the future and for future codings. So here we go.
Okay, we're going to talk a little bit about some of the functionality that's in VEXIQ code blocks and how to use the editor. This language is based on Scratch, so if you're familiar with that, this should be pretty easy to pick up on. There's a whole list of items to the left of the screen that we can put into programs. And I'm going to go through those and help get a little understanding on what they all mean and what we can do with them. First of all, every program is going to have a when started command. That's an event actually, and it is triggered when the program is started, when you first press the checkbox and run the program. So anything that's attached to that command, to that event, will trigger at that point. And if you haven't used Scratch before, in order to put commands or events or anything from our list into the program, we can just grab it and drag it, and it'll click right into the started block. And so I can grab any of these and just add them on there. And if I want to, I can just click on it and hit delete. That'll get rid of that command. I can do that again. And I'll do it one more time just to get rid of the start event. So I've put a whole bunch of commands in here. These don't really mean anything. It's not going to be a particularly good program, but we'll be able to go through and see what all these commands do. First of all, the gray command, the gray block is just a comment. Really good idea to have the teams go through as they're writing a program and just add a comment in and say, here we want it to drive forward, or here we want it to lift up, or close the claw. Next we have the motion commands. These are what you can do with external motors, the non-drive motors. You can pick your motor. We've already named these motors. We set them up in the devices earlier. We have the arm, we have the claw, we have the drivetrain. So this allows me just to pick my motor and say I want the claw to go open or closed. These again are items that we specified in the under the device earlier, our claw, we said open and close. And for the arm, we want up and down. So I can just select open or close for my claw, and this block has no limitation. It'll just close. It'll just keep running the motor until it'll just keep running the motor. You really want to tell it to stop at some point. This one will actually tell it to move for a certain distance. And 90 degrees, not necessarily how high it's going to lift the arm, because you may have some gearing, but how far it's going to turn the arm motor. And so we can specify whether that goes up and down, whether we want degrees or turns, which is, turn is a complete rotation of the motor. Degrees, of course, 360 degrees is one rotation. We can also specify if we want to wait. If we say wait, then it'll stay in this block until that motor's turned 90 degrees. If we say don't wait, it'll start the motor turning and then move on to the next command. So same with the position, we can tell it to move to what's essentially an absolute position. A common way to use this is just to set this value to 0, and that'll tell it to move the arm back to its starting point. And you might say don't wait for that. So it'll just start the arm moving and then continue with the rest of the program. The stop is something you might use when you told it just to open or close the claw or the arm. That'll just start it moving, and then the stop command will just simply tell it to stop. The set command actually resets the position of the arm. So if you move the arm all the way down to the bottom, then you may want to set that to the 0 position. And then all commands will be relative to that later on. The velocity, we can put a number in here, 0 to 100, tells it basically how fast we want to move the motor. Brake, we have options of brake, coast, and hold. Coast being it lets go of the motor once you've stopped it, doesn't try to power it or do anything. Brake means it tries to hold it in position, tries to resist movement. And hold, it'll actually actively try to maintain the same position. Commonly when you have an arm, you want it set to hold so that when you raise it up, it'll stay exactly in that position. Max torque is how much power it's going to use trying to hold that motor in position. Sometimes you don't want it going full power because that's going to cause the motors to heat up if they're working hard to hold something in position. And the timeout means if it can't move the motor for a certain length of time, then it'll just stop moving it. Those are all items for a single motor. Next we have items for the drivetrain. So these blocks you can set. Again, we have the drive forward. Just set it in forward and get out of the way. Here we have the drive forward for a certain distance. We can change this to 12 inches if we just want the robot to move a foot forward. We can also switch it to millimeters if we want. And we have the wait and don't wait. Here we have turn right and left. We can tell the robot just to turn endlessly. Here we can turn right for 90 degrees. There's a few things that are going to have an effect on this 90 degrees. The robot may not end up rotating 90 degrees in the spot it's in. Depends on the gear ratios that you have set up and the width of the robot that you set in the drivetrain earlier. All of these items will affect the actual turning distance And to some degree, the wheels, the size of the robot, how heavy the robot is, are going to affect how well it turns. This is something that will generally be consistent, but it's not 100% reliable in the turns that it makes. It's going to be close, but again, not 100%. Stop driving just tells it to stop however it's currently moving. Velocity, just how fast it's driving or how fast it's turning. What the robot does when you stop. Generally for the drivetrain, brake is a really good option because you just want it to stay in place, but you don't want it to fight too hard to stay in place. You don't want to use energy trying to stay parked there. And again, the drivetrain timeout, if it can't move after a certain length of time, it'll just stop driving the motors. We have a couple things here that don't really help the programming a lot. They can allow the programmers to put stuff on the screen if they want to put a message on there, say hello, or put a number, maybe one of their sensor values, they'll get displayed there. Or clear the screen. We can also play some sounds, play some notes. A lot of fun stuff can happen there. Our events, we already saw the started event, which takes place every time the program starts running. We can also capture other events like pressing the E up button or any of the buttons on the remote control. If we want a button on the remote control to cause some action to happen, if we want pressing the button to open the claw a certain distance or raise the arm to a very specific point, we can put that underneath here. We can look at when the button's pressed or when it's released. We can look at when one of the joysticks have moved, whether it's moved right, left, up, down. When one of those is changed, it'll raise this event and execute whatever commands are attached below it. We can also look at the brain. It's got the 3 buttons on it that we can access, the check mark, which means we could have an autonomous program that when the program's running, if you press a check mark, it'll execute some list of commands. You may also have a different one that says if the up button is pressed, then I want to execute a different list of commands. So I can have both the checkbox and the up box, up and the down if I want to. I can have all of those in a single program. There's also a timer. I can look at when the timer's past a certain length of time. Another slightly more tricky thing is the messages. And if I receive a message, I can tell it to execute a list of commands. I have another block that lets me send messages. There's a big description on what all that does. So I also have control, which is generally the flow of the program. One very common thing that we'll have in a lot of our driver programs, we'll have a forever loop that just goes on forever. And then we'll have blocks inside that will be executed. So we may tell it to drive forward forever. And then it may drive forward. It may have another function in here that checks the sensors. In some cases, we'll just want it to repeat that a certain number of times. We might also want a place where our robot drives forward and we just tell it to stop and wait for a little bit. There's a few other functions down here. Our if. Now we'll notice a lot of the numbers that we have here are in ovals. And things like the if block, we have this diamond shaped thing. Let me jump ahead for just a minute. And we can use different values to put in here. For example, this actually looks at the value of the timer. Any of our blocks down here, maybe we want this just to happen when the battery capacity is low. we can look at several of these different values. We can even put a combination of numbers in there. If we don't know how many times we want to repeat, we could have it repeat 3 plus 4 times. Or we could add some other numbers in there. If the battery voltage is high, then we want it to repeat this a lot of times. These round boxes just allow us to put any number in there. The diamond-shaped boxes actually allow us to put in a condition. So, is arm done moving? Earlier we said we could tell it to move the arm to a certain position and don't wait. Well, here we're going to check and see, is the arm done moving? If it is, then we'll have some code in here that we want to execute. We have an if else. If this is true, do this. Otherwise, do this. Wait until something. Common use for the wait until. You might wait until E up is not pressed. Well, and so this just returns E up pressed. But I want to see when it's not pressed. So I'm going to put not pressed. So now I'm going to wait until E up is not pressed. So that's how I can use these blocks. The break, there are times when you just want it to exit the program. Then you'll have a break command in there. There are a few other options that we have available to us. The sensing. Actually, as we add sensors into the program, we'll see more sensors available that we can put in here, which will give us more conditions available. We can create variables where we may want to keep track of a number stored in our variable. We can create my blocks. My blocks are essentially just functions, so I can put a separate function, a lot like an event, and whenever we call this function, it'll execute this function. And see, in this program, I've got it so that it'll execute this function twice, which will make it move forward 12 inches. That's a brief overview of the VEXIQ Code Blocks software and how to use the items in your menu. You can also hide the menu if you need to see a lot of the program. Hopefully that helps you out.
Okay, so how are we all feeling? I take another deep breath. I know that was a lot thrown at you, but we really think that all the information that we gave you today is going to be really beneficial when you have time to actually sit and do a deeper dive into it than we had today. We understand that everything that we went over today is going to take longer than just 1 hour, so we encourage you to watch this video going forward. We just want to reiterate that coding is difficult. It's not something that comes by easy, or else everybody would be doing it. It requires practice and determination and teamwork. So we want you all to try this again. Your teachers will receive this video again for you to watch at another practice or something like that. But we thank you for joining us today. Tomorrow we also have an intermediate coding class. And then on Thursday, we have our advanced coding class. So if you feel like today went okay, we encourage you to join tomorrow, but we'll also send out the video to all three. We'll send them out to everyone just so you have them on hand. So as your coding skills become more and more advanced, you can kind of watch those videos as your team grows. But thank you everyone for joining us today. We're super excited that you joined us. Feel free to continue to ask questions. If you have any questions, you can send me an email. I'll make sure that we get those answered. But have a great rest of your day and good luck coding.